Hello everyone, welcome to an algebra video tutorial. In this video, we're going to be making tables of values for exponential functions. I've got an exponential function here, f of x equals 250. We're repeatedly multiplying that 250 times 0.85. To the x power, x just means we're going to be multiplying it over and over and over again. I just don't know how many times I want to multiply it yet. But I want to make a table of values. Again, table of values are nice because they help us see the pattern in the function. We can take a function and it's basically choosing which x values we want to use and then finding the function with those input x values and then looking for patterns, looking for trends, seeing if we notice anything in terms of growth or decreasing function, and just trying to identify patterns. All right, so to do this, to make a table of values, it's simply doing a lot of calculations. So if you have your calculator, or I would recommend using the Desmos calculator online, it's a great way to do it. You can actually put in functions and let it do the table of values for you. But we're going to do it in the old-fashioned way. We're going to input things and go through and calculate these all out. All right, so let's take my function f, and we're going to first find it for an x value of -2. So in my function, I'm going to input -2, which means I have 250 times 0.85, and I put -2 in for x, so it's to the -2 power. If I put all that into my calculator and calculate that out, 0.85 to the -2, and then multiply it by 250, I get 346.021. So check your own calculations, make sure things are working out right. So my function, 346.021. Now let's just take a moment to think about this. My starting value is 250, right? So we went a -2 for x value, so it's kind of going backwards, which usually means when I do negative it goes smaller. But in this case, I'm taking 250 and I'm multiplying it by a fraction. So as I multiply it by 0.85, I should get smaller. But if I take 250 and divide by 0.85, which is what a negative exponent does, then dividing by a number smaller than 1 should make it bigger. So yeah, so I ended up with a bigger number. That makes sense because 0.85 is less than 1. Let's try it again. Let's do another one here. Let's do my function, this case for an x value of -1. Let's put in -1 for x. So I have the same values, 0.85, but now we're doing it to the -1 power. And if I calculate that out, I get 294.118. So my input value on my table, if I input -1, I get 294.118 back for my output. And we just are slowly filling out the table. This makes a little more sense now. So again, thinking about my pattern, as I increase from -2 to -1, as I increase 1 for x, that's an extra time where I'm multiplying by 0.85. So it makes sense that I'm decreasing right here. 346.021 times 0.85 should get me the 294.118. All right, let's keep moving. Let's keep moving along here. F of 0. This one's going to be interesting. So I got 250, 0.85 to the 0th power. That's equal to, well, if you remember my exponent properties, anything to the 0 power is just equal to 1, right? So this becomes just 250 times 1. So check it out with your calculator, but it's just going to be 250. And that's something that you can look for as you're doing any table values or any graphs or anything with exponential functions. If you're putting 0 in for x, for your exponent, it's going to make things really nice. We love 0 to the exponent because just everything turns into 1. So it's just 250 times 1. The whole thing is not 1, because that exponent only affects the 0.85, but still I get the 0.85 to 0 power is 1, and 250 times 1 is just 250. So there you go, that's the same thing as my starting value. All right, let's finish the rest of these up pretty quickly here. If I use my calculator and put in f of 1, again, putting it all in, I get 212.5. If I put in f of 2, again, following the same pattern, putting in just for the exponent, but f of 2, I'm going to get 180.625. F of 3 is going to give me back an output of 153.531. And my last one, in my function, if I put in 4 for x, what do I get back? I get 130.502. Okay, so a couple other things. Once we have the table, I should be able to check all of these, but I should be able to see the pattern that we're multiplying by 0.85 over and over again. Times by 0.85, times 0.85, times 0.85, and so on. So it's multiplying. We love to see that. We already pointed out when x is 0, there's my starting value. And the last thing is, notice how the change happens here from 346 to 294. That's a change of over 50 right there between these two, right? But from 294 to 250, that's a change of about 44. From 250 to 212, that's a change of about 38. The amount of change is different. And in fact, it's decreasing fast at first, but then kind of slowing down. From 153 to 130, that's only a difference of about 23. So we're seeing not linear growth, but we're seeing an exponential change. It's decreasing a lot, but it's starting to slow down. We're going to look at this more, but that's something to notice as your table of values is, are things increasing? Are they decreasing? Are they speeding up as they're increasing, or are they slowing down? All that kind of good stuff. We like to ask those questions when we look at a table of values. But there you go. We just created a table of values for this exponential function and tried to notice and point out really key things about it in terms of multiplying, the amount of change that happens, and key points. But it's just a lot of calculation. Calculation gives you the table. And once you have that, we can start to notice a lot of the patterns in our function.